Y'all, we're done with algorithms. Are you feeling good about that? Are you feeling happy? We don't have to talk about sorting anymore. I'm sure by the fifth sorting algorithm, you were like, I get it. We can sort stuff. I understand. We're now moving on to the tail end of the course. So I talked about this a little bit yesterday. We are now in our final and last module, module 13. It's called Days as a Developer. So over the next few days, we're going to do essentially a survey of some pretty important topics in software development. I would say my expectation for you all in terms of like what to get out of this and what you should expect. We're going to go through a ton of information. What I want you all to focus on is what is the tool or tools that we're learning about, and what's the big idea? What's the overall concept? What are some of the different tools we use with that? I think if you treat this as, oh gosh, I have to memorize all these things, it's going to quickly feel overwhelming and stressful. So we'll focus on the big ideas, and then for all three of these topics, it's going to be worthwhile for you all to spend time on your own, diving deeper into them and developing your skills with them. And we'll share some different resources so that you can do that as well. But essentially, we just want to leave you without having talked about these things, that you know about these concepts and can indeed dive in a bit deeper. I hope that means these lessons will be, in some ways, a little bit easier. We're talking about a lot of different ideas, but there's less precision, I would say, than with our searching and sorting algorithms of like, goodness, I need to figure out how exactly this particular algorithm works. It's going to be much more big ideas and understanding concepts. With that said, it is really important if you all have questions about anything, even if something's just like, can you say that again? Or can repeat that in a different way? To please do say so in live chat. It'll feel easy to sort of let this all just sort of wash over you and not really engage with it. I really encourage you all to be thinking deeply about these topics, ask questions as you need it to make sure you can get as much as possible from it. And of course, if you have any questions about how I've worked with these different processes and tools, I'm happy to answer that as well. All right, cool. Let's do it. Let's get into it. All right, so today we are learning about Git and GitHub. That is the plan. Uh, just a brief preview over here. You can see there's a lot of different slides to go through. Again, a lot of different information. I will do my best to make sure to highlight and make sure it's clear what information is, more or less important, what you can look up later as best as possible. There's also going to be some interaction with you all installing things on your machines, trying to get Terminal to work on your own. We will talk through that as we get to it, but everything should be able to be completed within Codio. But I'm going to give you all time to try and get some of these tools working on your own machine. All right, so in this lesson, you're going to learn what version control is and how Git, the most popular system of version control, can help you with your development. Furthermore, you'll create a GitHub account if you do not have one already, and learn how to use the built-in tools to create and merge changes to your code. So by the end of this lesson, you'll be able to know the difference between different kinds of version control systems, utilize and understand fundamental Git commands, and create and edit a repository in GitHub. That is the plan. All right, real quick, have you all already heard of Git and GitHub? Does that sound familiar? Did I talk about it at some point? Did David talk about it at some point? What do y'all think? Yes, yes, no to have you heard about this? We got a yes from Joseph. We got a yes from Chris. We got a solid yep from Omar. Okay, all right. So this is not 100% new, perhaps, but I'm sure we're going to dive into more detail here than perhaps what you've heard before. So consider if you're designing or working on a program like Microsoft Word or Excel, or even like Google Docs, Google Sheets, things like that, you typically have the ability to undo or redo your work. Depending on your settings, you can even view older versions of your documents prior to making changes. I guess I don't work with Word too much. I typically work with Google Docs, something like that. But with Google Docs, it's very possible to go into the history of a document and see who's made changes and sort of scroll forward and backwards in time. So this is really helpful in case something goes wrong or somebody wants to review your specific work, your specific contributions. And in this lesson, we're going to talk about software tools that help you do just that when it comes to coding. So that same idea applied to your code. We want to be able to track and manage the changes in our code. This is incredibly important to understand, especially when you're working on a code base with other developers. So source control, also known as version control, is a system that helps you track and manage the changes to your source code. It keeps a log of all the changes that were made, along with earlier versions of the source code. This proves to be extremely helpful when working within a fast-paced development team and environment. No matter the source control system you use, it will have a specific database that keeps all the changes that were made. So this helps developers go back and review the code to potentially find and fix the mistake. So again, there's many reasons why you might use Git and GitHub. The main idea of it is that it gives us version control. It gives us sort of a history, the ability to go forward and backwards with our changes to sort of inspect those changes. So in terms of what this would look like, why this is important. So imagine there's a team of 5 developers. Look at these guys all look so sad. This just like really feels like I'm probably gonna call this out a couple times. And it's like AI art. You just look at it and you're like, why? There's a mouse on the ground. Like why? They're so mad at it. They just threw it on the ground. Like there's a phone. A test. There's a lot of confusing things happening here. So imagine there's a team of 5 developers working on a company's website. 2 of them are working on bug fixes, and the other 3 are working on new features. All this is happening at the exact same time. The potential issue is when they write the code for the feature or find a solution for the bug, the different sets of code they've written might not be compatible with each other, which means the new feature may not work as expected or the bug isn't fixed at all. So you all have been working individually, right? You're working on your own code within Codio. Now imagine you and I, we're going to work together on some code. And you're changing line 3, but I'm down here changing line 35. And we start working on the same document. You all might have experienced this like working on a Google document or something like that that has sort of live editing and sharing. And it can very quickly get a little overwhelming where people are adding text, things are getting spaced down, you're getting moved around the page, you're trying to delete something, someone else is trying to write, right? It can quickly get a bit overwhelming. So developers have, uh, very quickly needed some way to be able to work independently on their own tasks, be able to merge those ideas together so that everyone's making progress. So that, for example, if I'm working on a new feature that happens to be connected to the same file you're working on, we can both work on those things at the same time and have a process by which we can make sure both of our new additions get added together and work as intended. Excuse me. So the goal of version control is to ensure that in situations like this, the source code is not impacted. And it really, we should say like source code is not impacted negatively, right? This happens by organizing the code for the software, app, or website into a file tree. This tree has branches that are assigned to each developer, allowing them to all work on the same project at the same time. It's inevitable people will be working on the same project in tandem. Version control provides a solution to the inevitable conflicts that would arise otherwise. When bugs or conflicting changes are discovered, they can be resolved without interfering with the work of other developers. So a couple things to this. First of all, we're talking about a file tree. Hopefully this doesn't feel totally mysterious to you all. If you all are working on a computer, you've probably managed files on the computer, gone into folders, right? Placed files in different folders, things like that. We actually have our file tree over here for this lesson. You can see here the overarching folder, we could say, is 13.1 Git and GitHub, and there's 2 files inside, a .settings file and an index.html. So that's the file tree, but if we were working as developers, multiple people might be working on just these 2 files. So again, version control's goal is to make sure that if multiple people are working on the same files, there is a process by which they can all work and manage those changes without causing a lot of issues. As I'm sure you all know, and probably part of the reason you're in this class is there are a lot of developers. Whereas before we might have had a smaller software engineering contingent in different countries or in your country of origin. Now, hundreds of developers could be working on a single web application, adding new features, fixing different bugs, things like that. So it's really important to be able to make sure that all of those developers can work together in concert while also working on various goals. So there's a few different types of version control. The two main that we'll spend most time talking about, and I'll share a video in a bit in this video to just talk about these latter two, is centralized version control system and distributed version control system. But we can also talk about local version control system as well. So a local version control system. This is when you manage all the files on your own computer system locally. All the changes you make are stored locally as patches. Every patch contains the changes made to the file since its last version. The problem with this is that it is easy to lose all files and changes if anything were to happen to your local system. So the idea behind this is that you have some file, and as opposed to just saving and overwriting that file, you are saving different versions of it. And maybe you all have had this experience, maybe individually or working with someone else where you have like, okay, here's my version of my essay of this document. And then you create sort of like a final version, right? Because you had to make a couple changes. Then you have like a final version. Then you have like a final version two. This process is essentially getting snapshots of different changes over time. Locally, you could manage these kind of changes if it was just your own code base and you were making duplications of all of these different files. You could go ahead and do that. As we'll see, most code bases involve tons of files. So copying over your version one and all the hundreds of files that are associated with it, and then creating a version two and just making a few changes there is going to be a little overkill potentially. And so that's why local version control, most folks are not doing this individually and on their own. So the idea behind a centralized version control system is that in this system, there's a server that contains all of the files and versions, and the developers pull the files onto their local system, making the changes, committing and uploading it back to the server, otherwise known as a repository. The issue with this system is similar to the local version control system. Something happens to the server and there are no backups, then the change history can be lost. Um, yeah, excellent, Joseph. Yeah, final version 10. Yeah, I think that's a very common experience for lots of folks of trying to figure out version control on their own, right? So for centralized version control system, it's very similar to a local version control system in that there's one place where all the main files live, and that is what we might call the source of truth. That repository is just a special word to say this is where it's hosting typically code. So it's hosting information. That repository is where all other developers, they pull information from that. They might work on stuff and then they would push their changes back to that shared repository. So what is nice about this is that there is one place where you know this is the real final version. There's no final, and like multiple copies sort of floating around. There's just the final version, which is the shared repository. And so developers at a snapshot can go and look at the shared repository and go, great, that's what's happening at this moment. That's the reality on the ground at this moment. And that idea will actually carry over to Git and GitHub. But it also means that multiple people can work with this shared repository at the same time. So maybe developer A is working on this part of the system, developer B is working on a different part, and they can sync their files with the specific files on the shared repository. As it shares here, one of the downsides that if something happens to this repository, this isn't just like some magical thing that lives off in the clouds. This is on someone's computer. It could be on a computer internal to the company, or perhaps more likely it's on some data center somewhere else. Something happens to that, either accidentally through some sort of catastrophe, or someone accidentally deletes a bunch of files on the shared repository and it's like, whoops, now no one has access to those anymore. It's just gone. So there's a big point of failure at the shared repository. There's the chance that something really bad could happen to all that work that's been done over time. The idea of a distributed version control system is kind of merging both ideas together in some way. So in this system, every developer has a local copy of the whole project on their computer. Since it is on their local device, they can make any change and commit to see how it turns out, and it will not affect the remote server. So what this means is, what this uh, this diagram is showing is that we have sort of our main version. This is version 1, 2, 3, And each computer for the developer has its own little copy of that, of the entire system. And when computer A or developer A is working on some new file, they can do that with their own system and see how that file affects the overall program. So as opposed to having to sync that first with the server computer, they can just do it all on their own, right? So I can add a feature on my own machine. I can see, hey, does this work as I expected it to? Is everything looking good? Does anything start to break as a part of my changes? And later, they can go ahead and push these changes to the remote repo. So once they're done, they can push these changes to the remote repository. This is useful if anything happens to the server, as any of the developers can send the files back onto the server to get it back up and running. So for example, if something happened to this server computer, in the previous example, all the developers are out of luck if something happened to the shared repository because their only interaction with the repository is to make changes to certain files, perhaps, right, on a smaller scale. In this case, if something happens to the overall server, both of these developers still have a probably mostly complete version of the code base. That's also true for the developers. So if this developer something happens to their laptop, it doesn't work anymore, they can't get access to their files, they might have lost some of the work that they were working on like just, a few days ago, but the majority of the code base lives somewhere else. So this adds a level of redundancy to the code so that everyone sort of has their own copy and version of it. And while they may be slightly out of sync due to the developers working on their own specific files, they're going to be much more closely integrated and they all have their own versions so they can test test their changes out, see how things work before merging it with the main server. So Git, as we're going to talk about, is an example of a distributed version control system, and this is what most developers tend to work with. All right. Uh, I think image has showed up a couple other times. What is happening in this image, you all? This keyboard has 12 buttons. I have so many questions about this. Is she like floating on a stage with the background? It's there's lots of things to have questions about. What's happening here? Does she have like military medals? It's very unclear. Anyway, so as you all are thinking about these ideas, can you all think of an instance where you wish you would have known about version control? What ended up happening, and how do you think version control could have prevented it? So what do y'all think? Are there any instances, perhaps in this class, where you wish you had some kind of version control, which would allow you to perhaps save work a bit more easily, or go back to something further in the past, or even outside of this course? Is there any opportunities where you wish you had some kind of version control? I see a few folks typing. What do y'all think? Can you think of an instance where you wish you would have had or known about version control? No, just I'm sorry to hear. So Joseph says, I was using VS Code, Visual Studio Code, some time ago to do a project and lost the whole code because I had some issues with the laptop. Yeah, that is a bummer. I'm sorry to hear that. Moving forward, perhaps you'll use Git and that'll help you out. That'll give you a backup. Omar shares, modified something in one of my projects and ended up breaking everything. Kept trying to figure out how to go and fix it and ended up in a worse situation. Basically had to start from scratch. I'm sorry, Omar. Also, these are both like deeply relatable, very, very relatable content. And yeah, I hear you on that. Particularly with code, like you sort of mess around with like, oh, let me just try and make this change, and suddenly nothing works at all. And you're like, how do I undo what I just did and work backwards? Yeah, Git can help with that, right? So if you make some changes and realize like, oh gosh, I need to just step back 30 minutes to what was happening before, Git actually has some really fantastic tools to make that easy to do. All right, excellent. So version control can be really helpful in a lot of different situations. Um, yeah, all kinds of different industries. I really think everyone should just be using Git and GitHub all the time for no matter what you're doing. If you're working on, I don't know, your schoolwork, you should use Git and GitHub. If you're trying to do coding, of course you should use Git and GitHub. If you're trying to do design work, something similar to Git and GitHub would be really nice. It just is very nice to have this sort of backup that is distributed, and that you have this full history they're able to go back and forward through. All right, so we've been talking about Git and GitHub, and it can seem like these two things are maybe just exactly the same, but they are in fact two different ideas, although of course very closely related. So you may have heard of both, but what are the differences between the two? Let's take a few minutes in the chat about what we may already know. So what have you all heard, if anything, about any differences between Git and GitHub? Is there anything you already know about the differences between these two things? If not, that's okay. Perhaps you've just heard about Git and GitHub, and that's been the end of um, your interactions with it. That's a-okay as well. Right. Tracker says I knew about GitHub, not about Git. Yeah, GitHub, I feel like just learning about development, you end up on GitHub pages. So it can end up being a bit more uh, popularized than Git itself. Thanks for sharing that. Any of the rest of y'all? Any differences you've heard about? Give folks a moment more to type. Just to share, I think I saw something about one being open source and the other is not. Sure, sure. All right, excellent. So let's start to describe some of the differences here. So Git is the most popular distributed version control system around today. As a distributed version control system, it is installed on your computer and allows you to see records and versions of different projects you're working on. Git has a unique feature called branching, which allows you to create your own unique branches containing your changes in the code, just like how we discussed file trees and file trees overall earlier. You can revisit older branches, merge, and or delete them easily. What I want you all to think about when you think about Git is the application that will be on your machine. It is the way in which you can interact with other code. All right. It is the main like tooling that you're using in order to manage changes on a code repository. In contrast, GitHub is officially known as a Git repository hosting service. This basically means that it is a cloud-based online database that allows you to upload, control, track, and share your projects outside of your local computer or server. I love this. This basically means it's just a cloud-based online database, right? That makes tons of sense. You can share your projects and code with anybody around the world, and you get access to, and they can make revisions and changes to your Git branches. GitHub offers an intuitive interface and essentially turbocharges Git functionalities. So GitHub is our website, is our application that allows us to explore Git uh, via like a regular browser, a regular graphical user interface. Git, the program, is going to require you all to work in the terminal. And I guess actually there's some tools that allow you to avoid the terminal, but for the most part, you're working like on your machine to manage specific files. Git and GitHub over time have a lot of the same functionality. So GitHub will give you a lot of features that normally or in the past you'd really only be able to do with Git, and Git now can interact with GitHub in ways that it used to not be able to in order to leverage the user interface part of GitHub. So there's now like a ton of overlap, and they really are uh, very complementary and something you work with together. But I just want to be really clear, it is possible to work with just Git and not GitHub, and it is possible to work with just GitHub and not Git. Git is the programs on your machine. GitHub is in the cloud. It is the website, the application that you are working with. And as it says here, it's a cloud-based online database that allows you to upload, control, track, and share projects outside of your local computer. So when we're talking about that distributed part, GitHub is a huge player in that. It will host your code for you and serve as that kind of main backup, but other people could then influence that hosted repository, the hosted code base that is up there. So that's the difference between these two things. Before we move ahead, we can go to this slide. So in summary, Git is a distributed version control system, and GitHub is a hosting service that is cloud-based. So Git lets you manage and track your source code, while GitHub lets you host and manage your Git repositories. Before we move ahead, I'm just going to share this very brief video. It just talks about Git overall. I don't know if I shared sounds, or let me stop sharing here and make sure I have the sharing permissions set correctly. All right, excellent. So this is just talking about Git, but I just want to show this to you all so you can get just a bit more color on what Git is.
So what is Git and why is it so popular? Git is the most popular version control system in the world. A version control system records the changes made to our code over time in a special database called repository. We can look at our project history and see who has made what changes, when, and why. And if we screw something up, we can easily revert our project back to an earlier state. Without a version control system, we'll have to constantly store copies of the entire project in various folders. This is very slow and doesn't scale at all, especially if multiple people have to work on the same project. We will have to constantly toss around the latest code via email or some other mechanisms and then manually merge the changes. So in a nutshell, with a version control system, we can track our project history and work together. Now, version control systems fall into two categories: centralized and distributed. In a centralized system, all team members connect to a central server to get the latest copy of the code and to share their changes with others. Subversion and Microsoft Team Foundation Server are examples of centralized version control systems. The problem with the centralized architecture is the single point of failure. If the server goes offline, we cannot collaborate or save snapshots of our project. So we have to wait until the server comes back online. In distributed systems, we don't have these problems. Every team member has a copy of the project with its history on their machine. So we can save snapshots of our project locally on our machine. If the central server is offline, we can synchronize our work directly with others. Git and Mercurial are examples of distributed version control systems. Out of all these, Git is the most popular version control system in the world because it's free, open source, super fast, and scalable. Operations like branching and merging are slow and painful in other version control systems like Subversion or TFS, but they're very fast in Git. We'll talk about this later. So Git is almost everywhere. More than 90% of software projects in the world use Git. That's why almost every job description for a software developer mentions Git. So if you're looking for a job as a software developer, Git is one of the skills you must have on your resume. You should know it inside out, you should know how it works, and how to use it to track your project history and collaborate with others effectively. If you want to learn Git, I have a 1-hour tutorial here on my...
All right, great. There's a 1-hour tutorial for if y'all can follow this later. There you go. So as I was described in this video, right, Git is open source, super fast, scalable. It is performant in many ways and is indeed free to use. As we'll see, GitHub is also free to use in a number of different ways, although there is a paid version of it. Hopefully that helped explain a little bit about Git, sort of just solidify some things that we just discussed. So again, Git is that local application, and GitHub is a hosting service for hosting those code bases, those repositories that we're going to work on. Excuse me. So repositories in Git and GitHub contain all of your project files and revision history. So repositories can be owned by single individuals, or they could be shared amongst other developers. You can collaborate or restrict access to anyone if you own the repository. You can use repositories to discuss and share feedback, report bugs, and seek out solutions to coding problems. A repository essentially is tracking all the changes you make to a file and saves the revisions. It saves this data in a repository folder called .git. And like we mentioned before, Git uses version control system software to track and save all changes made to a project. So again, as it says here, a repository essentially is tracking all the changes you make to a file and saves those revisions. So it is not necessarily keeping a copy of the entire project at multiple stages, but it keeps track of what changes occur over time and can undo or redo those changes. It says here that it saves this data in a repository called a .git folder. This is a folder, and whenever you all see something that begins with a dot, that typically means it's a like hidden file or hidden folder. So just something to know. If you poke around in your file system, by default, you probably won't see any of these dot files because they are supposed to be hidden. Often they deal with configuration or often just mean like, hey, this is something you don't want to mess with unless you really know what you're doing. All right. And this next step, we're going to do some individual work here to install Git and Git terminal on your machine. Really quickly, I don't think this is the case, but I just want to confirm. Have you all done any work within the terminal, um, like with David or anything? And I'm particularly thinking about like taking a look at files within here or something like that. I think the answer is no, but I just want to confirm before I start talking about something you all have already learned about. You all have not spent too much time in here, right? Running commands like ls or cd or pwd or something like that. Do I have that right? I don't know. I don't know if I have it right. People are thinking, does Wes have it right? It's unclear. Yeah, it's just as shares. No, just node. Yeah, so I remember us talking through, I think we just ran files with node, right? We would say node script.js, something like that. All right. That is all good. This particular lesson is not on the terminal, and yet we have to work with the terminal here to really get GitHub to work. So I'm going to try and talk through a little bit of this. I think we have enough time to do a brief overview of this. I won't spend too long on it. Yeah, so we'll see where we get. This is just going to be one of the many things to cover in this lesson. So first, before we get into any of these details over here, this is a terminal, right? So we've talked about this. I think I remember talking about this with you all just briefly. We were learning JavaScript and we ran our node program to run some JavaScript files. This terminal, back in the old days, long ago, this is how you would interact with our computer, right? This was our main way of interacting. And or you may look at this and go, ah, we're in like a hacker movie. Cool. I just need to hack into the mainframe by typing a bunch of commands right here. All right, so this is an interface with the computer. We typically work with computers through a graphical user interface, a GUI, which is us being able to like drag stuff around, right? We can click on buttons, we can see how things work, we can drag and drop things. That's giving us a visual idea of what's happening on our computer. But to be clear, this is an equally good, it is an equally valid way to interact with our machine. While we have these in Codio, you all can also get access to a terminal locally on your machine. So this is a terminal for my machine. In here, the way to interact, as opposed to by clicking on buttons, right, or even using keyboard shortcuts that necessarily won't necessarily work here either, is you would type different commands. So for example, the command ls, I'll make this a little bit bigger. Hopefully you all can see this okay. Ls will list all uh, all folders and files within my current directory. PWD stands for print working directory. And so this gives me the full file path to our current place here. So we have access to a whole bunch of different commands that'll tell us where we are in the system, what we're doing, and we can even create files and edit files within the terminal. So you could even create a text file in here and edit it within here. You may have seen before me type or perhaps the Codio type the command clear, and it's gotten rid of everything. That is because that is the command that you run to clear the output within your terminal. So terminal is also something that as software developers, it's really crucial to get comfortable with. I will say now there are so many tools that allow you to kind of avoid the terminal in some way that you can't kind of get away without being a total expert on this. At least it's been some of my experience. I would say though, you're never going to be able to avoid, at least as of yet, working with a terminal for a number of reasons. But it's just always going to kind of come back to being able to work and run different files. You're always going to want to be able to have some experience with the terminal. So I'll close out this for a second on my local machine and just sort of point us over here. So on for all of you, you should have access to a screen like this that says terminal. If you all type ls within here, you should see an index.html file within the current folder. Your current folder is listed right here, and it's called workspace. Everyone should have their own individual. I believe that's what Codio does. It basically spins up its own little container. So you have your own little workspace. That way we can all work individually. So go ahead and just try that out. Go ahead and try just typing ls, oops, not ks, ls within the space, and you should see index.html underneath it. Go ahead and just give me a thumbs up in chat or something if that does indeed work for you. All right, we're getting several people are typing. I love it. Thanks for the thumbs up, Joseph. Sorry. Chris, Omar, excellent. All right. Yeah, so you all have access to type around in here. So LS allows us to list. Ooh, we got like a flex from Tatiana. Perfect. LS stands for listing. We're listing the files that are viewable within this folder. Go ahead and try this next command, which is PWD. So PWD stands for print working directory. That working part means where you currently are. And directory refers to a folder. So if I do print working directory, I see something like home, Codio, workspace. This little bit, this is the file path. You can think of it as the address to my current location. It's the address to my current location. So right now I'm within the workspace folder. So if you all have like opened up files and folders on your machine, you've probably seen those little folders. You can click in to get inside of one. Right now I'm inside of that workspace folder. Okay. So in this, like on this machine, in this case on Codio's machine, but we'll also do it on our own machine locally. This is where we're going to work with Git. Again, Git is the application for our own machine. So what this slide asks you all to do, and let me talk through this before you all get started, is to basically get access to a terminal application on your computer. And we're going to go ahead and see either if you already have Git or potentially installing Git locally as well. So there's two steps here. The first is to install terminal on your own machine. Real quick, how many of y'all are using a PC or a Windows machine? And how many of y'all are using a Mac? Been sharing that in our chat. All right, everyone's on Windows. I wish you the best of luck. I have essentially no idea how to help you. I always work on a Mac. But there are some instructions here on how to do so. So the first thing you want to do is get access to your terminal application. So for Windows folks, you can go ahead and click this link right here. This will give you some instructions on how to set up your Windows terminal. It should essentially just be installing this, and then there are some steps here to make sure it's easy to find. Okay. So I will give you all a few minutes to do that. No one's on a Mac, so I won't talk about Mac instructions, just to say it's easier. So sorry about it. I don't know what to tell you. Excellent, Tatiana. Happy to see. Happy to see. A lot of commands are the same. So in general, go ahead and get started on that. If you all have not already, in terms of getting the terminal to work. In general, the commands should really be the same for uh, PCs and Macs. The thing you might notice, and so if you take a look at Tatiana's screenshot, the direction of these slashes is different between Mac and Windows. And I'm sure there's an interesting origin story for that, but it basically just makes it annoying more than anything else. So just something to keep in mind. You might see that I have forward slashes here, and if you're on Windows, you're going to see backslashes. So it's just a minor difference just to keep an eye out for. All right, so let me give you all a few minutes to get this installed and hopefully open it up and get a similar screen to what Tatiana is seeing. Once you have that, go ahead and give a thumbs up or share your little screenshot that you got it working, and then we'll move on to the next step. Excellent. Chris got it working. Thanks, Chris. Sarah's got it working. Nice job. Give everyone just a couple more minutes to try and get the terminal working. If it ends up not working, that's okay. We will have access to it within Codio, but we have some time. Let's go ahead and try and get it working on your machine. All right, just got it working. Excellent. All right, Omar's got it working. Happy to hear. All right, well done, y'all. So feel free to take more time if you need it to get terminal up and running on your machine. That is a-okay. Or again, if you're encountering a bunch of problems, you can just step back over to Codio and that's fine too. So the next thing we can do is now that we have terminal open, actually, before I move forward, let me just say, in general with terminal, I'll step back even further. In general with software development, if you delete stuff, if you know, accidentally remove things, it's usually not a big deal, right? It's like you can undo stuff. It's pretty easy. When you're working in terminal, pretty much the same for the most part, unless you're running something complicated. It's probably going to be a safe operation to run. That is, there's not going to necessarily be any super big downsides to whatever you're playing around with in here. I would say with anything on the internet, just copying and pasting it and just being like, great, I hope it works is a little dangerous. With commands in the terminal, you want to be really careful about what you're running in here, particularly if you don't understand what it does. So there are certain commands that can remove files from your machine. You don't want to run that unless you know that you want to remove those files. There are certain commands that can copy information and send it. Yeah. So it's not quite I mean, working in Codio, you've had a very safe space to like, you know, break all kinds of stuff and run infinite loops. When you're working the terminal, you do want to be a bit more conscious of what exactly it is you're running. I don't want to say that to make you afraid of playing around with it. It is very resilient. Your machine is very resilient. There's not going to be a lot of stuff you can do without really trying to that is going to cause a bunch of problems. But in terms of just copying things on the internet and pasting them into your terminal, I would be a bit careful about doing that. Omar points out that Linux doesn't have a trash bin. Something's deleted, it's gone. That is the case. If you delete stuff on via your terminal, does not go to your trash bin. It is deleted. So just something to be wary of. The commands you're looking for as well to be wary of are something like rm, which is remove, or maybe even rmdir, which is remove directory. If you see a command that is doing something like that, you want to make sure you know what exactly is going on. All right, that's my caveat. You'll all be fine. It's probably fine. Don't stress too much about it. Just want to make sure you know. All right, the next thing you want to do is we want to go ahead and check to see if already on the machine you have access to Git. So you could do something like git dash dash version, or just type in Git and you'll see some output. Why don't you all go ahead and try that? I don't know if you all will have Git. Mac does install Git by default, but you all let me know if you run this command, which is git space dash dash version. Does anything show up for you, or does it say something like cannot find Git or can't find path to Git, something like that? All right, excellent, Joseph. Cool. 2.38. Oh, I'm behind. Yikes. Living in the future. All right, how about the rest of y'all? Are you able to get the Git version running? Tatiana says, lucky me. Yeah. Well, in this case, you actually just typed in a version. So try and type in the full command here. So the full command is going to be git space, and then it'll be dash dash version. Just like with JavaScript, command line commands that you put into your terminal are very fussy. There's no like, oh, I understood what you meant. It's you gotta type it in exactly as it shows right there. Yeah, okay. The error that wait, sorry, who is this? Someone Chris sharing? Yeah. This is kind of what I would expect to see. So this one says the term Git is not recognized as the name of a whole bunch of different things. Okay. That is a-okay. If you all already have some issues with Git, that is just fine. Okay. So if that is the case, you're going to go ahead and you can try and install Git. So installing Git for Windows is right here. There's a Git for Windows installer. You can follow the instructions here. I believe pretty much what you'll need to do is just download, and then you may want to close terminal and reopen it and see if that changes. Again, I'll give you all a few minutes to try that out. If it still doesn't work, that is a-okay. We'll move past it. I don't want to get stuck here trying to get everyone's individual installations running, but that'd be a great thing to perhaps schedule some time with Veronica to help you out, get something installed, or go ahead and ask for some help in extra help. Those could all be good ways to make sure things are working. So go ahead and take a few moments and follow the instructions here on this Git for Windows installer and see if that helps those of you out who do not have Git installed. Those of you who do have Git installed, You get to just close your eyes for a brief moment and be chill. Just relax. All right, any changes for you folks that did not have Git running? All right, Chris, sorry, Tatiana, still were you able to get to work? Still not working? Okay. Still downloading stuff. Sure. All right, excellent. Chris has gotten it working. Cool. Sorry, it says installing as well. All right, all good. All good, all good. All right, well, feel free to continue that. I'll yammer a bit and just talk about the next little task here. But it's a good idea to get this up and working on your computer so that you all can practice it moving forward. So the task down here has us submitting the version uh, of Git that is inside of Codio. So again, to do that, you can type in the word Git and then dash dash version. And sorry, I'm saying the word Git, but I mean the program Git, so Git version. Um, just some notes here. So Git is the program that's running. Remember, we used to run Node, right? Git is our program that's running. Whenever you see a dash dash like this, or also sometimes just a single dash followed by like a single letter, this is called a flag. So flags will usually modify how the program runs in some way. So in this case, we're saying, hey, Git, just tell us what version you are running. So for me on Codio, it's running version 2.17.1. And you all can submit that in here, depending on what version of Git is running in your Codio, which I assume is the same, but I don't know. Maybe you got some cool upgraded version of Codio and I don't. I wouldn't be shocked. All right, so that is our Git program that we have. So we have that locally on our machine. Again, this is what's going to allow us to manage files, things like that. All right, there are a ton of commands, and I don't really know. I'll be honest, I was looking through this for a couple of days and trying to figure out like what is the best way to go through this. I think I'm gonna sort of breeze through these commands a little bit. I think this is a good resource to go to. I'm just gonna try and highlight some of the main ideas here, and then we'll go over to the practice part, and we can run through some of the commands that it asks us to go through and really talk more in detail about what exactly is happening there. Because I think just hearing a bunch of commands may not really stick in any solid way. I think the practice will probably be the most helpful thing. But let me quickly talk about some of the different commands you can run with Git. All right, so on this page, it talks about some different commands called git config, git init, and git clone. So you'll notice in order to run these commands, it starts with the program name, right? So git is the program itself. If you just put git in here, you'll see you get this huge amount of output. This is because you've invoked the git program, but you've not given it a command to run. So what typically happens um, with a lot of different command line applications is that just typing the name will often give you this kind of like help screen essentially of like, hey, it looks like you were trying to do something with Git. Maybe use one of these commands. Up here where it says usage, this is giving you I think as a new person to terminal, this just looks like nonsense, doesn't it? This is trying to be helpful and share some options for what you can um, use with Git. You actually see right here version, right? So one of the options is to give it this flag version. And then you'll see a number of different commands down here as well. We're going to talk about some of these commands explicitly. And so you can see there's something like clone and init. We just talked through those, right? We'll talk a little bit more about what exactly they do. There's some other ones like add, move, reset, remove. We have diff, merge, rebase, all kinds of different things we can do with this Git program, all related to version control and managing our files. So one of the first things you could do, and I would not really do this in Codio, but you could do this on your own machine, is git config. So git config allows you to set up your name and email so that it's associated with any changes that you make. I believe right now it might just say your computer's name, or might say like anonymous or something like that. So git config is a way to add configuration to your Git program that's running locally. Git init is the command that's used to start a new project or create a new repository. So what that means is right now we are in our file system. That means we're in a folder. Right now we're in the workspace folder on Codio. You might be in a different folder on your own machine. And within this folder, the folder right now is not a Git repository. In order to make it a Git repository, you have to run this command of git init. The reason you do that and what it does, and we talked about this a little bit earlier, is it will make a .git folder. And a folder with a .git folder within it, a hidden .git folder, that is a Git repository. That is the way it is indicated. That is a Git repository. And that gives it some special powers and some different kind of commands you can run as well. And git clone is a command that in this class, we're not really going to use this, but in the future, if you are playing around with a repository, git clone allows you to pull down a version of an entire copy of an existing repository from something like GitHub, which can be pretty powerful. All right. There are some other ideas here. I don't know. How useful is this without seeing an example? I think, sorry, let me do one thing. I just want to click around here a little bit. Yeah. Okay. We have a bunch of commands here for working in a project. So the idea of what's going to happen is we will create a Git repository, and then we'll be able to manage those files in different ways and decide if we want our changed files or our new files to be part of our commit history or not. So just to add some clarity to that. So git add, both these commands allows you to add files to what's called a staging area. So let's say I start with an empty folder, then I make some new file. Right now, that new file lives on my local machine, but is not part of the Git history just yet. So to begin the process of adding it to our Git history, I would first add it to our staging area. The staging area is kind of like you can imagine we're getting stuff ready to decide whether or not as part of the history. Git commit we'll take anything that's part of the staging area and go ahead and commit it to our history. So when we're talking about those different versions that we saw earlier of sort of like version 1, version 2, version 3, a commit creates one of those versions. It creates a commit that will track changes that are made. That could be a new file. That could also be adding a single character to an existing file. So any changes that happen, a commit will hold on to that change. And that is one of the ways you can go back and forward in time with Git, is by traversing through commits and through the overall commit history. Git status will give you an idea of what's currently happening on your machine in your staging area. So we'll see this, but running Git status will give us a little bit more information about what we've done within Git. And one of the main benefits of working with Git is that you get to build branches. This can be a little bit confusing at first, but the idea is that you have a main branch, that's where most of your code lives, and then you could branch off from that and do a little bit of work for a while, and only later come back to the main branch. It's basically a way for you all to work on something individually without messing with the main code base. So again, I'm not going to talk through all of these different commands because I think it'll make more sense once we really get into the example. And then git checkout is, I believe this is like slightly an older term, but this allows you to switch between branches. I believe you can also, depending on the version of Git, also run git switch. The only other couple commands I just want to discuss very quickly. Ooh, there's a lot in here, but we talked about pushing and pulling changes. So once you have commits, once you have changes that you want to push back to the main repository, you would use git push. That's you pushing up your changes. In contrast to that is git pull. Let's say you're working on a team with 5 other developers. They make a bunch of changes and you want access to those changes. You would then pull down those changes with git pull. And these other commands allow you to sort of play around with some of the final state of your changes. So git stash allows you to take what you're doing and just stash it locally on your machine so it doesn't mess with any of your current history. This is nice if you're like trying something out and you're like, I need to get back to my regular work. You can stash changes. Git merge allows you to, if you have 2 people working on different commits, you can merge the different histories together to try and get the code base back into a single state. And Git remote allows you to get some information on that server, on that repository that's hosted in the cloud, and do some configuration with that. So as you all have seen, there's a lot of commands here. We've just sort of briefly gone through them. Let's talk through the practice here, and then we can start to see a bit more and really visualize what this ends up looking like. So I'm going to ask you all to go over to Codio and not do this on your local machine, just to make sure you don't do anything confusing on your local machine that I won't be able to assist you with. But in this case, we will just play around in the workspace over here. So remember, we do still have access to Git within here. We have Git version, right? We can still work on that. And right now we are in this folder called Home Codio Workspace. So to prepare ourselves to practice with Git, we're going to follow a few different commands. The first thing we'll do is run git init. So you all can follow along with this on your own Codios. So run git init. You should see a few things change. First of all, you should see this line appear where it says initialize empty Git repository in this working directory, right? So home Codio workspace, and then we see this .git folder. Similarly, if you look to the left over here, you should see there's a folder over here called .git. The next step we're going to do is we're going to go ahead and make a new folder called project. Now, with a graphical user interface, you might do something like right click, new folder, and give it a name. On the command line, we'll need to use a command to do that. The command we use is mkdir. Make this a little bit bigger, so you all can see. So this represents make directory. That's what it's saying here, make a directory. Directory is just another word for folder. So we're going to make a directory, and then we'll give it a name. So the name of that directory will be project. Again, the idea is that we're running a program called make directory, and we're now giving an argument, kind of like we would a function. And that first argument is going to be the name of the directory, and that is project. If I hit enter on that over here, I'll see that I now have a new folder called project. Let me pause there. Go ahead and give me a thumbs up once you get to that step. So you should have run git init and you'll see a .git folder show up here, and then make dir project, and you should see a project folder show up here. Once you've gotten that, go ahead and just give me a thumbs up in chat. Excellent. Thanks, Asari. Give the rest of y'all a moment. All right, we got a thumbs up from Tatiana. We're gonna thumbs up from Omar. Excellent. Yeah, thumbs up from Joseph. It sounds like it is going well. A thumbs up from Chris. Love it. Love to see it. All right, excellent. So we have now initialized a Git repository. We know that is true because we have a .git folder, and we've created a new directory called project. Next, what we're going to do is we're going to run this command called cd project. CD stands for change directory. So I'm going to say cd project. You also can run this, and you should notice that the path at the very end down here is a little bit different. It now says workspace project. What change directory does is it changes where our location is on the command line. So previously we were inside of the workspace folder. We've now moved inside of the project folder. So that's where we live right now. So when we run commands, we're running them from the project directory. The next thing we'll do is we are going to create an index.html file. To make the index.html file, we're going to use a command called touch. Touch is a program that, when given a file name, will go ahead and create that file for us. So if I say touch index.html, over here on the left, we'll see that an index.html file has been created. And last, it just says, let's add some generic HTML code in there, nothing fancy. So I can say something like, really, we need the whole doc type. Will autocomplete that for me? No, I don't want to do all. Oh, wait, right there, right there. There we go. Oh, that's it. We can add a head. Oh, God, the autocomplete's not, it's not doing it for me. We could add a body. We should probably have an HTML tag. Right? Is that needed? Let's say yes. And I'm just gonna go ahead and type something like this in. All right, cool. So the steps we followed, we cd'd into project, we created a new file with touch index.html, and then I just wrote some HTML in here. You all can do whatever kind of HTML stuff you want. So let me give you all a second to do that. Once you're done with that, go and just give me a thumbs up in chat. I know our chat's just gonna be a ton of fun thumbs up. That's a-okay. Yeah, let me know if y'all have any issues with any of this or any issues with like opening up stuff on Codio. I know that can be kind of weird sometimes. All right, more thumbs ups. Love it, Chris. Thank you. All right, thanks. Sorry. All right, excellent. Thanks, Joseph. Excellent, y'all. So what we've done, again, we've created a new folder called project. Nice job, Omar. We've created an index.html file, and we've added some HTML within here. We've also made our workspace directory a Git repository, right? We know that again because it has the .git folder. All right. So what we're going to do is we're going to do some practice now with the actual Git commands. At this point, the only Git thing we've done that's specific to Git is run Git init. Everything else has just been command line stuff, right? So we haven't really worked with Git too much besides making it a Git repository. So now let's go ahead and run some of our more Git specific commands. So it has a little bit of like a check right here. I think we're going to take a look at the solution because I think there's a lot of commands. I think it's kind of difficult to sort through these with so little practice. So we're going to first create a new branch called a test branch. I think what a branch is will come into focus as we do so. So we can take a look here at what the first thing it suggests we do. There are a number of different ways we can make branches. This is one of them, but let me just go ahead and show you all a few things here. If I type in Git here, right, it'll give us a whole bunch of different commands. And so one of those commands, if you didn't have a solution over here on the left, is take a look at this little helper and see, okay, well, I want to make a branch. So it says git branch, right? And this allows us to list, create, or delete branches. Let's go ahead and just type in git branch. Hmm. Oops, got to spell it right. Git branch on its own is not necessarily doing anything. Let's try something like this. So let me actually get out of here real quick. So a lot of times you can add dash dash help as a flag to different commands. And this will work for Git, but also will work for a lot of other programs as well. So if you try and run something, you're not sure, like, what am I doing here? You can try and run help. If you do this, right now we're brought into, it might look a little weird, it might feel a little weird. What this is a particular type of reader, essentially, that the terminal has access to. You'll notice you may be able to scroll. I can scroll mine with my mouse wheel. You might also just need to press like up and down, depending on what kind of machine you're working on. And you'll see at the very bottom down here where it's highlighted, it says press H for help or Q to quit. So if you want to get out of this page, you can just type Q and that'll get you out of it. What we're looking at here, though, is this is the Git manual for Git branch. We can see here it gives us a ton of different information. It describes some of what you can do with Git branch. It gives you some options of what you can do, which looks like delete. We can create reflog. Who knows what that means? We can force something to happen. We can move things around. We can turn off colors. There's all kinds of different actions we can do. But just to give you all some context in this, um, it is not important as a developer, even as a software developer, if you like really want to get to know Git, to memorize all of these different ideas. There's going to be certain things you do often that'll be worthwhile to memorize. But for the most part, you need to know how to look this kind of stuff up, not to just have this all in your brain. I have some Git commands memorized. I do not have all these commands memorized because I don't use them all the time. So if you ever need to sort of figure out how something works, I know it ends up being a lot of reading, right? But there's always a fallback of using the manual here. We can always, of course, Google around, find other kind of commands, but this is I would try and get comfortable with this as best as possible. I know it feels kind of overwhelming, but these often can be written, if not amazingly well, at least very detailed. And so you might be able to find a bit more information about the thing you're looking for, or a bit more, I don't know, direction on maybe what to search on Google, something like that. So let's see if there's a couple examples that are a bit more complex I'm seeing here. Excuse me. Da, 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 da. I think you can just give the branch name here. So I kind of just want to try that. And then I want to see list. Yeah, okay. All right, so I'm going to get out of this by pressing Q. One of the commands I saw was list as a flag. So it's listing branches. Right now it doesn't show any. Dash L, nothing coming through. Okay. Let's go ahead and try a branch name. So I'm going to go ahead and just give a branch a name of Wes. Oh, not about object name master. Hmm. All right. Well, let's try to do something clever here. Let's go ahead and follow the instructions that are over here where it says git checkout dash B and it says test branch. All right. Excellent. So this command over here, what this does, git checkout, if you remember I talked about it just briefly, git checkout will move you to a new branch. This dash B will create the branch, and that branch is called a test branch. List here how to do so? No. Let's try git branch again. status here. Okay, cool. I'm just gonna get back to where you all were at. So we ran this command git checkout -b test branch. So what that does is that creates a new branch called test branch. You can't really see anything right here as to whether or not that worked. We run git status. Git status, remember I talked about that. It gives you sort of the status of what's currently happened. What we'll see here with git status is we're currently on branch, test branch. It says there are no commits as of yet. And they have a bunch of untracked files. These untracked files are things that we have not made any commits on yet. We have not added these files to the Git repository. And so we can see here it says nothing added to commit, but untracked files are present. You can use git add to go ahead and track some of these files. Cool. So that was our first step. We created a new branch here. Our next step is we're going to go ahead and go back a directory. The way you go back a directory, right now we are in the project directory. To go back, we can do cd // It can also just be cd .. So cd .. the .. represents up one directory. So if I say cd .. you can see this changes from workspace project to just workspace. So my current location is at workspace. If I run git status now, you'll see a little bit of a difference between these two git status commands. Here, we see the path that is given for the untracked changes is up a directory .codio, up a directory .guides, up a directory index. Whereas now that we're in project, it's just saying .codio, .guides, .settings, index, project, things like that. Hopefully your, oh, there's two indexes. That's why. There's also the project folder. Right. Got it. Let me pause there. Let me know if you all can get basically to this step. So we've run git checkout -b test branch, and we've run cd -- slash. Just let me know if you were able to get there. Excellent. Thanks, Joseph. Thanks, Chris. Thanks, Omar. All right, cool. This is kind of stuff that if you do it right, it's very easy. And then if you type something wrong, you can feel like immediately lost. So I apologize if I'm going a little slow. I just want to make sure everyone's following along. All right, so now what we're going to do is we're going to add our project directory. So we can run git add project. This is going to add our project directory and start to track the changes to this. After running git add project, we can run git status. And you'll notice there are some changes yet again. The changes to be committed include this new file that we've created. All right, it's included this new file that we've created. Cool. All right, so what we've done now is we've moved project/index.html to be part of our staged section. So all these untracked changes are sort of down below, and then we are staging this project index. The last thing we'll do is we'll make a commit. So if I run git commit -m, and then I'm going to give it quotations that need to be matching. They could be single or double quotes, but they need to be matching. What this is saying is I'm going to go ahead and make a commit, and I'm going to give it a message. This is the -m, and that message is going to be whatever goes between the quotes. So I might say something like my first commit. If I hit enter, we'll see a few things change. First of all, over here, you can see it's actually tracking that we are on a test branch. So that's kind of interesting. We also see down here, we get my first commit, and then it says one file changed, 7 insertions. That might have to do with the 7 lines that are in this file. Kind of cool. And then it has some details about sort of like configuration details for Git itself. So we've now committed this change. What does that mean? Well, if I run git status, you'll see this file looks like it's no longer here. That's because what Git is seeing is that, okay, there's some files that I'm not tracking. That's these red files, right? I'm not starting to track them yet. And there's some other files that I am tracking, but there are no changes to that file. So if I head over to my index.html, let's say I make a few changes to this file. I'm really excited to say hello world now. And I rerun this, we'll see that now Git is keeping track of those changes. It sees that there were some changes in project index.html. So it actually sees some of the differences there. So that is the role of Git, right? When you commit something, it's saying, great, that's the state of things as they are. And then when you start to make changes, Git goes, I see some changes are happening. Do you want me to commit those? Should I get rid of them? What do you want me to do? So that's the role Git plays. If you're all able to get there, fantastic. I'm gonna go ahead and see if we can get back to our main branch now. Are there any other branches in here? This is very strange. It seems to have not created anything. Well, that's okay. All right, we just have one branch. I guess that's perhaps it's just the version or configuration that's in Codio. All right, so we've created a branch, we've created a commit, and we've made some changes here, and we can see how Git ends up tracking those changes. Let's take a look. That is kind of our Git practice for now. So this was pretty shallow in terms of practice overall. Let me see. We're at an okay point. I'm just going to pull up my terminal here. Let's go in here. Let's see if I have any Git repositories in here. Yeah, okay, cool. At some point, I was doing some work for Correlation 1 on some of our curriculum. So let's check over here. I'm just going to show you all a few things. Let's do, what's the normal size for this? That's not too big here. Let's do that. Okay. So right now, you don't need to follow along here. I'm just going to show you a couple examples of things, then we'll take our break. So right now, we can see that right now I'm in a folder called SD5. That's in my correlation 1 folder. That's in my WestC1 folder, which is in my users directory. Fair enough, Tatiana. Um, So what we're looking at here is there are a bunch of files in here. Oh, there's one file in here. Let me do ls-la. We can see there is some stuff in here. If I go back up a folder, we can see I can sort of navigate around here and take a look at some different files in here. Right now, this will output, what this is showing me is that I'm on the main branch of this Git repository. So I'm on the main branch. What's in the main branch is just these files. That's it. We see we have a Git repository. We have a Git folder. We have a .gitignore file. That's a special Git configuration file. And then we have some README right here. The checkout command allows us to switch branches. And I'm going to switch over to, let's say, Wes 8.3 form handling. This is I'm swapping over to a new branch over here. Now, if I take a look at the files in here, you'll notice it's different. I now have 3 additional folders in here: components and props, state and event handling, and form handling. So the differences between these two branches, on the main branch, it looks like we just have a few files, whereas on the form handling branch, there are a bunch more directories. So right now, we might describe my form handling branch as being ahead or having additional changes that the main branch does not. And again, it's just one of the benefits of working with Git. You can sort of separate some parts of your code, be able to work on some stuff before merging it back in to, for example, a main branch. So all to say, these are the kind of commands you would end up running to manage your project. A typical workflow is you have a main branch. You do some work on your own branch. There's lots of different naming conventions for this. One that I typically follow is like my name dot information about what it is I'm working on. I make some changes here. I'll make commits, and then later on, I can merge those commits back to main. That allows me to manage my own version of my code without messing with whatever's happening on the main branch. Right now, there's not much, but you can imagine there being a lot of code already on there. And as we'll see, repositories can get quite complicated and have lots and lots of files. So it's nice to be able to work on your own as opposed to constantly conflicting with others. Okay, we can stop there. So we've played around a little bit with Git. We've talked about version control. We've tried some commands on the command line. Again, I know this is just like a lot to go through. I'm asking you to type some stuff. We haven't really worked with the terminal. There's a ton going on here. I believe the purpose for this lesson is really just to give you all sort of dip your toes into some of the things that you might be working with in the future. So we've talked through some of the details of Git. We'll go ahead and take our break now, and then when we come back, we'll wrap up by talking about GitHub, which is the browser uh, version, the way that we host a lot of our repositories. So go ahead and take a 10-minute break, and then when we come back, we will continue on with GitHub.
Awesome. So we'll come back at 38 after the hour. So see you all shortly.
Go ahead and share my screen. All right, well, since it's making so much sense, lucky for you all, there's a nice fancy little quiz right here. So this is just to help you all get a second to review Git. Here's how I'd like you all to treat this. So our next little slide right here, there's a bunch of different questions on how to do different things with Git. What I would like you all to do is, based on this, go ahead and step back through the Git commands slides to find the different answers. So some of these will be things that we directly covered within here, but others are going to be things that we talked about super briefly. So I'll go ahead and put a little bit of time up on my screen. We'll give you all 4 minutes or so to make some guesses on this, and then we'll come back together and talk about it as a group. All right, so go ahead and get started on that little quiz. All right, just another minute to answer those questions. All right, excellent. Hope y'all had enough time there to do a bit of research and figure out the answers to these questions. Let's go ahead and start with the first one. So what is the purpose of the git config command? What did you all figure out from these four options? Tatiana's on it with the gifts and the responses today. All right, so to set the author name and email address for commits, go ahead and check it. That is indeed correct, right? So config is pretty much just setting information about your commits overall. Let's go to the next one. Which command is used to start a new repository? Yeah, Chris and Tatiana jumping in here. Git init. Let's go ahead and check that. Exactly. So remember, that is what we uh, ran at the beginning of our practice to establish it as a Git repository. We can tell something's a Git repository because of the .git folder. All right, for this next one, I feel like people are getting ready. Which command saves uncommitted changes for later use? We did not really talk too much about this one. All right. Nice job, Tatiana and Timo. Let's go ahead and check Git stash. Yeah, so stash, remember those uncommitted changes, those the changes that are in red. If we wanted to just like move those away, get them out of the way from our staging area and everything, we can run git stash. How do you create a new branch in Git? How do you create a new branch in Git? Yeah, I see some options coming here. So git branch, we'll go ahead and do that. We can check our answer. Checkout switches to a branch name. Merge will merge branches. We didn't really talk too much about that. We'll actually see an example of that with GitHub, I believe. And git branch dash D does the exact opposite. It's going to delete a branch. So let's make sure not to do that one. That is git branch. All right, nice job, y'all. Nice job doing the research on these and walking through it. All right, so moving from Git to GitHub. So again, we've talked about Git, the program, locally on our own machine. Now we're going to go ahead and take a look at GitHub, which is a little bit different. So first, let's take a look at a couple of Git repositories here. I'll give you all a second, but for example, we can take a look at React. You all have worked with React. Well, where does React come from? React is just another Git repository, right? We're downloading React and we're using the code that's within the React code base. This is a GitHub repository as we see it on GitHub. We can tell we're on GitHub because this cute little octocat icon, that's what they call it. It's a octopus slash cat for whatever reason. And there are a bunch of options up here. And then we have the actual code base right here. You can see there's a ton of like configuration files and things like that. And then a whole bunch of different folders in here, within which are even more folders. And we can find probably even more files and folders, etc., etc. So this is a GitHub repository. This is a popular one, so it's going to be a big one. But this is not uncommon by any means. So some things we can notice here. Again, we have the actual files themselves, and so we can look at the actual files that are used to create React. Uh, Here's like the git ignore for React. Let's see if we can find something more interesting, maybe that has what would have some JavaScript in it that we could take a look at? Maybe in here. Uh, maybe this. We can see there's some JavaScript in here that's running React, all kinds of code in here. All right, so this is the actual code base for React. So with GitHub, we get access to the actual code itself. We also get access to this sort of about the sidebar, gives us more information about the repository itself. We can see there's some tags that have been added here, a website for it. We can see how many people have starred or watching or have forked the entire repository. Forking is basically making your own copy on GitHub. We can see how many people are using this repository, 25.4 million. Wow, that's a lot. We can see who has contributed to this GitHub repository as well. We can also see the number of languages that are in here as well. There's also a README associated with it and tons of information down here. GitHub also gives us access to all these different tabs and useful collaboration tools up here, such as issues, pull requests. These are things that are getting worked on with React. We can also take a look at all the different branches that are with React. So these are all the branches that are currently up and accessible on GitHub for React. These are probably fixing bugs, adding new features, all kinds of things. So hopefully y'all can see there's a lot going on here, right, in this GitHub repository, and a ton of people working on this thing, and they're all able to do so because of GitHub. Tailwind CSS is a CSS framework. It has lots of some nice, cool ideas with it, and you can see this is just another slightly smaller but still quite used framework and repository that has a ton of people using it, a ton of contributors, and a ton of files. I bet if we look around in here, I don't know, where would maybe be scripts? No patches? I wonder where maybe the main files would be, but I don't know. Post CSS. Dude. So a lot of this is just JavaScript. Well, we can see some JavaScript in here in order to get this framework to run. So lots of stuff, lots of different files that go into most GitHub repositories. So what we're going to do first is we're going to give you all a little bit of time to create your own GitHub account. If you do not already have one, you're going to follow the link here and follow the instructions on this page. This link will bring you to the GitHub homepage, and then you can go ahead and follow the instructions to sign up. You're welcome to use your I guess usually I'll use your personal email, and there may be a few steps here. The GitHub sign up process has changed a number of times, so hopefully this is still mostly correct. If not, there might be some additional questions you have to answer, something like that. The page you're trying to get to is this one. All right, where you can kind of see like a landing page for GitHub. So I'll give you all a few minutes to do that. I'll go ahead and log into my GitHub as well. When you get there, uh, go ahead and share your GitHub profile in the live chat. So go ahead and take a few minutes on this page and go ahead and make your new GitHub profile. I'll see if I can sign in here. So you want to get to something like this, following these instructions. And thanks for sharing, Joseph. Exciting. Excellent. Thanks for sharing, Omar. You know, a few more minutes to create your accounts. Excellent. Thanks, Sarah. Love it. Right. Nice, Tatiana. Cool. It looks like folks are able to sign up. All right. If you're still working on it, that's a-okay. Go ahead and finish up. So once you get to your GitHub page, depending on if you've done any work for it yet or not, you should end up at a landing page like this. This will, in the future, show information of different repositories you're following or people you're following, or maybe just, repositories that are related to some of the languages you're working with. You can always go to your profile, which is github.com/your username. And that'll show you some of the repositories you worked on, some of the contributions that are public, and you can get access to all of your repositories as well. So all kinds of stuff that you can get access to within here with just a free GitHub account. I don't pay for my GitHub account, and I still have access to all of these things. So that's our GitHub account. So with a GitHub account, it's just kind of, in some ways, like any other website. You have the profile, you have access to different content, things like that. Once you have one of these, you will be able to make repositories that can be hosted on GitHub in the cloud. So we can go ahead and make a new repository by following these steps. I'm gonna do this. I'll put this to the side, and then we can put this over here. I'll go ahead and follow along with the steps over here. So on all of your individual GitHub profiles, we're going to make a new repository. To do so, the first thing you're going to do is you're going to click on this little plus button up here, and you'll see there's a number of new options that you can do. You're going to go ahead and choose New Repository. It's a pretty common page you might get to while you are practicing with GitHub. We can take a look at some of the options here of what we can do. We're just going to fill in a few of these. Yours right here for owner should probably just have your account name because I have a bunch of different organizations that I've started and become part of. That's why it's asking me. If you need to choose it though, you're going to go ahead and choose your own GitHub username right here. So that is the owner of this repository. For the repository name field, you can really fill in whatever you want. The suggestion here is to put in hello world. Your repository name will need to be a repository name that you do not have, right? So you can't make 15 repositories all called hello world. If you need an example, you can click on this little green text, which will give you a randomized, very silly name. We can write a short description down here. This is indeed optional, but we can go ahead and write one. So I'm going to say an example repository for the Git and GitHub lesson at C1. Right here, you can choose whether or not this repository is public or private. You are welcome to choose private. This will allow it so that only you can choose who can see and commit to this repository. I'm going to choose public just so I'm going to share this with you all in case you wanted to see anything. But again, you have either option here. In this case, we're going to select add a README. This is going to give us a file to begin with in our repository. It depends on what you end up Doing it through repository, you won't always check this. And once that's happened, you should have something that looks similar to this. And you can go down here and click Create Repository. Once you do so, you should be brought to a new page that is your new repository. If you take a look at the URL, it's github.com/your username/your repository name. So that is now your new code repository. You can see the description is over here, and we have one file in this repository. Our one file is a readme.md file. So that is the readme.md file. That is all we see. Once you get to this page, go ahead and just give me a thumbs up in chat so I know you all are following along and not moving too quick. So again, you should be at your own repository. Awesome. Thanks, Tatiana. Thanks, Chris. Thanks, Joseph. Sounds like we're doing good. All right. Excellent, y'all. Thanks, Timo. So we now have our first repository. So our next step here, let's just like poke around here a little bit. You can see that it says here your repository is one branch named main. So typically all repositories are going to start with a main or master branch. Main is the newer name. You can create additional branches off of this main branch for different versions of your project. And these code changes, however, will not appear in your main branch until you merge them. In the meantime, you can use these different branches to edit and experiment before committing the changes to the main branch. So initially, we just have our main branch, which is our default. That is sort of our source of truth for the overall repository. Okay. We can also see over here, we have some other options. We can click around to look at a different kind of view for all the branches. Again, right now there's just main, but in the future we could see additional branches. We can click in on specific files. We'll see that we're going to be able to edit files as well. All kinds of things we can do on this page. So what we're going to do next, we're going to go ahead and make a new page. Or sorry, a new branch. So what we will do is we're going to be on this code tab right here. There's a number of different tabs up here. We're going to make sure we're on the code tab. We can then select this little drop down. And then right here, we can type in a new branch name. So we can say first branch. When we do that, we get this option that says create branch, first branch from main. What that means is we are taking the current state of main and we're copying that over to our first branch. So I'm going to go ahead and click that. So now we can see that I can go to main, I can go to first branch. These will look exactly the same because they basically share the same history. There are no changes, there's no differences between these two branches. Once we're here, though, we can start to make some changes to our first branch. So what we can do is, first of all, let's make sure we're on first branch, and then we can click into the README file here. I click into the README file. I'll have some options here of how I can look at this. This .md file is a markdown file. I can't recall if we've talked too much about markdown. It's just I don't know what I want to say. It's a specialized way to sort of write documents that'll appear in a certain way. You'll notice I have a few options here. I can look at the code for this file. This is our markdown file. This gets rendered and looks like this, but this is the actual text that is within that file. There's also this tab called blame, which is a great name. It sounds very accusatory. But as we'll see with, we can look at other repositories. We look at the React repository and click the blame tag. And this will tell you who has done what work on which line. So if someone introduced something that is not working or someone wrote some beautiful code that you want to commend, you can go ahead and use this blame tag to blame them for that line of code. On this page, what we'll do is we'll click this Edit File button, which is the little pencil icon over here. If you click that, you will get to this page. This is in Markdown. Markdown is thankfully not too difficult to figure out. It just has some special symbols to denote certain sizes of text or certain styles. So right now, a single £sign tells that we want to make a top level heading like an H1. on the page, and then regular text just looks like regular text. So I could say something like I can do 2 $ and say something like a little about me, and then write something like, I'm just looking at the example over here. I am really enjoying teaching this course. Outside of this course, I can give some options here. What do I like to do besides coding? Is there anything else in my life? Okay, I like my dog. I like reading, and I like hanging out in my hammock. Is that how you spell hammock? I think so. So go ahead and make a few changes to this file. All right, take a moment to type a few things in here. You could just add some exclamation points if you really want, but I don't know. Take a second to share something interesting about yourself. You can check to see what the output looks like by clicking this little preview tab right here. All right, and that'll show you what this looks like. So I'll give you all a moment to do that. Once you are done, go ahead and click that Commit Changes button, and you will see something like this pop up. And just before we move forward, just give me a thumbs up once you get to this step, after you've made a few changes to your readme.md file. All right, thank you, Chris. Thank you, Timo. What did you all add? You got anything interesting about yourselves? What else do you all do besides come to this course? Thank you, Joseph. Excellent. Thank you, Tatiana. As your favorite team. Excellent. Cool. Yeah, whatever floats your boat. All right, so once you all are at this step, so what we've done, just to sort of step back before we make this big commit, this huge commitment. So we created a new repository. As part of creating that new repository, we created a new file. That was just part of the GitHub setup process, right? On that repository, we then made a new branch. Our branch is called first branch. You can see that kind of faded out right here. Our main branch doesn't have any changes on it, and so we're making changes first on our branch. On our branch, we're making a little bit of an edit to our README page. I've added a little bit of information about myself. Maybe I'll have added your favorite team, maybe information about yourself, your hobbies, whatever you like. And now we're going to go ahead and commit those changes. So kind of like with Git, where this is sort of teed up for us to make a change, but we haven't actually committed that change to our our Git repository's history. So we have a couple options here. We can add a commit message. That this is just like that -m, whatever you want to put inside of the quotations. Update README is a fine commit message. And if you wanted to, you could add a extended description. So I might write something here like added a little bit about myself. Down here, you'll see a couple options. You can see here I have some options of like who I can commit with, what account I can commit with. You all probably just have the one email, that would be my guess. And then you have two different options here of what you want to do with this commit. There is an option to create an entirely new branch for the commit and start a pull request. We'll talk about that. But in this case, we're just going to commit directly to our first branch. So once you are ready, you can go ahead and click Commit Changes. That'll save those changes. And really, you shouldn't see much of anything change from this page. There's not much that is too different. However, let me show you a couple things that have changed as a result of that commit. The first thing is I'm going to go back to our main page here. You might see this little call out if you head back to your main page. We'll talk about that in just one moment. We'll see a little call out here says this branch is one commit ahead of main. What that means is our current branch has one new change, one new commit that is different than is ahead of main. And main is just in the past. If we took a look at, if we click on this link right here, it'll bring us directly to our commit. So our commit is actually a thing that Git and GitHub are keeping track of. So GitHub will show us what that commit was and what exact changes happened. So for example, here we can see it's showing with these green lines where there's a plus, it's saying these are lines that were added. And you can change view here. So if I go from unified to split, it'll show you here's what was there before, and here's what was there now. This is all part of that main commit. The other thing we can do is we can take a look at this little icon right here, this little, I don't know, clock icon. It looks like it's turning back. And this will show us all the different commits. This right now, I guess, is on main. Let me go over to first branch. This will show us all the commits. So we had one commit here, which is our initial commit. That's when we created the repository. And then we have another commit that is the update readme commit. This is on our first branch. You can see here, I can show the description. Notice if I switch between main and first branch, right? First branch has this commit, this new commit we just made, main does not. So if I head back to the code tab and take a look at main, notice our readme right here doesn't have those new changes. If I switch over to first branch, it does have those changes. So right now, GitHub is keeping track of two different versions of a repository. The main branch has just the basics of what we initialized the repository with, and the first branch has our new changes as part of that. So that's what we're doing. We're making changes and adding them to our branch. Next thing we're going to do is we're going to make a pull request. So a pull request is a type of interaction where what happens is we're basically suggesting changes from one branch to another. Often what's happening is you're making a suggestion from, hey, I want to suggest these changes from my branch to the main branch to merge them into the main source of truth. But you can add to any branches. You can compare and merge to any branches. So to make a pull request, there's a couple different ways we can do it. We actually could just click this button right here, but let's go ahead and follow the instructions over here. So we'll go ahead and click on the pull requests tab up here. We can click new pull request. Right here, what it's saying is it's comparing the base and comparing main, but they're both main right now. So what we're going to do is we're going to click the branch that we just made changes to. Oh, actually it says down here, example comparisons. We can click your first branch or first branch down here. And notice up here it says it's comparing first branch to the main branch. We'll see some of the changes that are getting suggested. And so the changes, just like that commit we just looked at, the suggestion of what is to be changed is we're adding this information about ourselves to this README. So you should see something like that. And again, if you have the unified view, it'll look like this. Once you confirmed, yes, these are indeed the changes I want to make, you can go ahead and create a pull request. We're still not quite done yet on this page. On this create pull request page, you can add a title. So I could say something like pull request to add more information about me. You'll notice I already have some text in here. This is from that commit description. It gets auto-populated in here, but you could add whatever it is you want. The last step is to go ahead and create our pull request. Excellent. Cool. So we'll see a few things here, but let me pause and go ahead and just give me a thumbs up if you're able to get to this step. So again, what we did was we went to the pull request tab. We followed a few steps to compare first branch with our main branch, and then went ahead and created a new pull request. So if you've gotten to this step, to this page, then it looks like this. Go ahead and just give me some sort of emoji in our live chat. Excellent. Thanks, Timo. Appreciate it. Excellent. Thanks, Joseph. Oh, we're doing great. We're doing excellent. Excellent. Thanks, Tatiana. All right. Not bad, y'all. Sounds good. So if you're still completing that, that's a-okay. Go ahead and move forward. I'll talk about this page a little bit. So a pull request, again, we're making a suggestion from one of our branches as to what we should do on, in this case, the main branch. So we're comparing our first branch to the main branch. The only commits that are getting compared right now are just that one, that is the difference between the main branch and the first branch, right? So GitHub takes a look at the histories of both these branches and goes, first branch has a new commit. Fantastic. Let me add that. That's going to be our comparison for this pull request. Now, what would really happen here on a real development team is you might add a new feature, add some new content, you make a pull request, and then someone else on your team would likely review it, run some tests on it, do whatever it is they need to do to make sure that this code should be added to the code base. And so you can see there are some options up here of how to record that or do that. You can actually choose reviewers. So for example, if you were in a GitHub organization with your team members, you'd be able to pick from your reviewers to come in and add reviews to your code. You could add, and someone else could add reviews to their code as well interactively. So I can add a comment right here that says something like, hey, let's pick a new title, or there's a comment about some code of like, I think this might be a little bit inefficient. Let's try this, right? They can actually add reviews to this. And then as a team, you'd work back and forth to comment on the code, make changes, push up new changes perhaps to your branch to accommodate some of those changes that are suggested by your coworkers. They're automated rules and things that you can run as part of GitHub. So for example, perhaps every time you push some code, it goes ahead and goes through and checks like, hey, does this code immediately break? It'll run some tests on it, right? There's all kinds of things you can do. And then GitHub also has some project management tools as well, which I don't think we'll go too much into, but you could use here by attaching it to a particular project, attaching labels to it, something like that. Let's go ahead. I'm just going to take a look at the React repository. We take a look at some of the pull requests here. So you see there are a ton of pull requests here as well. And these are a bit more updated. So we can see a real like GitHub pull request has some information about what this pull request is trying to do. We can see stuff like error reproduction, how to reference a specific issue that has been tagged on the GitHub itself, steps to reproduce. There's a number of commits down here that allow someone to sort of break up their changes into multiple steps. This check mark right here is likely from tests passing successfully, so GitHub integrates that. And then you can see over here, it's a label here, CLASI. I'm not quite sure what exactly that means, but there's a couple participants and some information happening here. It looks like there's a couple workflows awaiting approval. This probably means that someone needs to come through and actually take a look at this before it gets merged in. So pull request is a really common step for software development teams and a really great way to manage a lot of changes coming in to a repository. And we can see that here, right? Folks are busy. Folks are busy working on React and fixing up lots of small and large problems. All right, hopefully you all have gotten to this step. So the last thing that we need to do to get our main branch and our first branch in sync with one another is actually merge those changes. So if there were some conflicts, we would see them as part of the file changes. You'd typically see, I guess what would it look like? It'd probably have like a merge conflict note, and it might be red or something that's going to show there's some issues here. We can see there's no conflicts here. There's nothing to worry about. So we can go ahead and confirm the merge. So right here, you can click on merge pull request. That's this button right here. It'll then swap out to this new little page here where we can get a short summary of what happened and then go ahead and confirm that merge. Once we've done that, we've merged a commit into main that includes our new commit. And we have the option to now delete our first branch. You may feel a little bit precious about your branches, but as soon as it's been merged, there's really no reason to be. You can go ahead and just delete this branch. This will delete the branch from GitHub, but our commits have been moved over to the main branch. So we can go ahead and take a look at that. If we head back to the code tab, we'll see here we now have our new content, right? That's nice. We take a look at our branches. We just have the main branch. We have indeed deleted that branch. And if we take a look at the commit history, we'll actually see we have our initial commit, we have that commit we made, and we have a new commit that is a record of us merging that pull request in. So essentially a record of this merge having happened. And so now our main branch includes all the changes from our first branch. Of course, this example is small, right? We just made some changes to a text file essentially and merged those in. But you can imagine, of course, when you're working on a real GitHub repository with real code, the number of changes that are included in here might be much larger. Ooh, I've been talking for a bit. Let me pause there. Any questions from y'all on this? Anyone encounter any issues? Any questions on like how or why we use this? I know there's a ton of information here. I hope, we're just trying to sort of skim the surface, but anything that is coming up for you all, any questions you're wondering about, either from today or for the future as a software developer? So many whys, but all good. Well, you're welcome to ask them as well. I mean, you can keep your secrets if you want to keep that close to the chest, but happy to answer if there's some things left unresolved. All right, folks are feeling fine. You guys are an easy crowd. Just kind of like, yep, I trust you, Wes. Everything you're saying must be correct, so I will not question it. I mean, easy for me, but if you have questions, that's okay. All right. Well, all cool. I think that's the last one. I think that's the last side. We've got recap and closing remarks. Okay. Let me expand this. I'm going to close out of that. All right. So we talked about a lot, too much. I'm impressed and shocked you all said you were feeling good about this at the break. That's credit to you all for hanging in there. There's a lot of information in here. So let me just take a moment to kind of wrap this up. Um, fair enough, Timo. To wrap this up and just try and join some of this information together. So again, today we talked about Git and GitHub. The reason we're talking about Git and GitHub is because as a software developer, it's unlikely that you're ever going to be working just by yourself on a product. More likely than not, you're going to be working with a ton of other developers to build all kinds of different tools and work with them to solve bugs, right? Add new features, all kinds of things. To work together, you could, I mean, if y'all have ever done a group project where you've had to like work on a slide deck or something like that, it's like it can be nightmarish, right? If everyone's deleting slides, moving things around, right? So I'm sure you all have had experiences where it's been a struggle to try and work together on something. When you have 3, 5, 10, 20 developers working on the same product, even if it's across the code base, right? Even if you're all kind of working on different files, it can still cause a lot of friction. And so Git and GitHub, or more generally, version control systems, are designed so that you can more easily work alongside other developers, work on your own projects, but still be able to collaborate and have everything working together on a big GitHub repository. So Git and GitHub are two tools that allow us to do that. Git is our local version. We work with Git on our machines. We installed, for some of you all, Terminal and also installed Git. And so we can use the Git program to do some of the things like adding changes, making commits locally on our machine. GitHub is the cloud-based version. I don't want to necessarily say that. GitHub is a cloud repository for tons of GitHub repositories. It's where you can go and see code and you can collaborate with others on code. Git and GitHub can connect to one another. That is one of the main ways they work. We don't really cover that today because I'm guessing there's just a lot of little things that can come up. But what you would typically do as a process is you would work locally using Git to add commits, make change, all kinds of stuff like that. And you'd push up your changes to GitHub. So you'd be taking your local changes and pushing them up to GitHub. You then do that on a branch. And from that branch, you could then make a pull request, and another member of your team would then give you feedback. You'd work together to work through to get the code into a good state, and then you'd merge those changes into your main branch so that it could move out to the real website, real application, whatever it is you're working on. So it's definitely a complex process. It can feel complex at times, but it's really like just fantastically smart as you all work with larger projects. I'm sure learning Git will be stressful, but I hope at some point you'll find that Git is really quite powerful in terms of the tools that it gives you, and you'll, I think, quickly see the benefits that you can get out of using Git and GitHub in concert. So again, the goal of this lesson is really to give more of a survey more than anything else. There are a number of additional resources over here. Um, there are a few different videos that can give you more information on getting started with Git. There are a ton of videos online on getting started with Git and using Git. And so I'd really encourage you all to get started with that. It may be best to start with some videos or tutorials that help you work with command line so you can start to feel comfortable there first, and then work with Git and GitHub. This is definitely one of those skills that there's so much information, you could overwhelm yourself trying to study it. And so instead, it's really just about practicing, right? So there's some key commands in on the command line that are really essential, being able to navigate around, being able to move, create new files. And then with Git and GitHub, it's kind of the same thing. There's some key commands of being able to pull down repositories, pull down changes, push up your changes, and then manage changes locally with git add, git commit, things like that. Once you have some of the basics, you can definitely make a lot of progress. And then a lot of those other tools will come into play as you need them. Whenever you have sort of an inkling of like, I wonder if there's a way to do this, or I wonder if there's an easier way to do this thing. That's a great signal to try and look up, search around the internet to see if there's an already existing Git tool for that. And there probably is. There's a lot of tools associated with command line in general and Git and GitHub overall. All right, we will end it there. That is the end of us talking about Git and GitHub. Tomorrow, or when Thursday is software testing, so we'll talk more about that before we talk about Agile at the last lesson.